In this video tutorial, we are going to solve some problems based on percentage. And the first problem is find 1% of 1 hour. So if you have to solve this one, that is 1% of 1 hour, then you can take two different approaches. The first approach is you can simply convert this hour into minutes. So 1 hour has 60 minutes, right? And the second approach can be to convert this hour into seconds. So if 1 hour has 60 minutes, so now each minute has how much seconds? How many seconds? It has 60 seconds. So 60 minutes will have 60 times 60, that is 3600 seconds. Right? So the first one is this one, that is just convert this hour into minutes, and the second approach will be to convert this hour into seconds, minutes and seconds. Now, what is 1% of 60? Surely this gives you 305 minutes. 305 minute, right? Now, what about this one? 1% of 3600. This gives you 36 seconds. 36 seconds. Okay. Now, B1. In this B, 75% of 1 kg. 75% of 1 kilogram. Again, two approaches. Either you keep it into kg only, don't change this unit. Okay, so keep this unit as it is. That is, you have to solve 75% or 75% of 1 kg. And the second can be you change this kilogram into gram. Convert this kilogram into gram, right? So in 1 kg you have 1000 grams. Therefore, in this case, you calculate 75% of 1000 grams. Now, even you can convert this kilogram into milligram and so on and so forth. But here, for our discussion, we are only taking kilogram and gram, right? Because you can further convert this gram into milligrams and so on and so forth. So 75 or 100 times 1, it gives you what? It gives you 75 or 100, and this gives you 0.75 kilogram. Because in this one we have not converted this unit. It is as it is. But in this case we have converted. So 75% of this one is 750 grams. Right. Find the value, find the whole quantity if 70% of it is 40 minutes. Find the whole quantity. So let's solve for the first one. 70% of it is for 40 minutes. Then what is the whole quantity? Let the whole quantity be x. Okay, let the whole quantity be X. Now 70% of X is what? Is 14 minutes. This gives you 70% of X is 14 minutes. This becomes 70 times X 100 is equal to 14 minutes. Cross product, so 70 times X is equal to 1400 minutes. This gives you X is 1400 over 70 minutes, and this becomes X is equal to 20 minutes. So the whole quantity that has been asked here is X 20 minutes. For the B1, 8% of it, that is 8% of the whole quantity, is 40 liters. So let the whole quantity be X. Okay, 8% of X is 40 liters, and this is 8% of X is 40 liters. This gives you 8 times X for 140 liters. This gives you 8 times X for 1000 liters. This gives you X as 4000 for 8 liters. This gives you X as 500 liters. So the whole quantity is 500 liters. Out of 15,000 voters in a constituency, 60% voted. Find the percentage of voters who didn't vote. This is the first part of the question. The second part of the question is, can you now find how many actually didn't vote? So first focus on this first part. Find the percentage of voters who didn't vote. So how many voted? 60% voted. We are solving for the first part. 60% voted, right? Now clearly this 15,000 voters, of the given constituency represent what? They are 100% voters of that particular constituency, right? Imagine that in a particular city or in a particular constituency, there are only 15,000 voters. So registered 15,000 voters. It means that this is actually the 100% of voters present in the constituency. Okay. So if of this 100%, 60% voted, then of course if we subtract 60% from 100%, we get 40%. It means that this is that amount, this is that percentage of the voters who didn't vote, right? So 40% didn't vote. Now the second part of the question asks, can you now find how many actually didn't vote? So this is the percentage This is the percentage of the voters who didn't vote. Now you have to tell the exact number of voters who didn't vote. To solve this, we take two parts, two different ways. Okay, in the first way is like 40% of these many voters didn't vote. So 40% of 15,000 didn't vote. It means that 40 over 100 times 15,000. If you solve it, you get 4 times 1500. So this becomes 0, 0, 4, 5, 20 and 6. So 6,000 voters didn't vote. They didn't vote, right? The second way is using unitary method. How can you solve using unitary method? Now, clearly, in this case, 40% didn't vote. It means what? It means out of 100 voters, 40 didn't vote, right? 40 didn't vote. So you calculate for 1, that is a unitary method, for 1, 40 over 100. Therefore, for 15,000 voters, how many will not vote? How many have not voted? Or how many didn't vote? 40 over 100 times 15,000. Right? This is using unitary method. Now you can clearly see we have the same calculation here, right? We have to perform the same calculation. Now if you solve this, you are going to get this 6,000 voters only. You save rupees 4,000 from your salary. If this is 10% of your salary, what is your salary? Now we don't know about salary, so let's assume, let the salary be X. Okay, let the salary be X. You save 4,000 from your salary if this is 10% of your salary. So again, two ways. The first way to solve it is 10% of the salary, that is X, is equal to what? 4,000. That's what it says. If this is 10% of your salary, so we are assuming, let the salary be X because we don't know about X the salary. So 10% of X is 4,000, and if you solve it, you get 10 over 100 of X as 4,000, and if you solve this, you get 10 times X as cross product. This is 1, 2, 3, 4 and 5. This gives you X as 1, 2, 3, 4, 5, 10. You get X as rupees 40,000. The second way is using unitary method. Right? So, what does it say? It says that from this 10%, you save rupees 10 for every rupees 100 of your salary, right? So you save 1, that is a unitary method, for rupees 100 over 10. Okay. So for rupees 4,000, how much you save, or how many you save? That is rupees 100 over 10 times 4,000. And if you solve this one, you get rupees 1, 2, 3, 4, 5, and 10. This gives you rupees 40,000. Same amount. So it's very important, to know the unitary method to solve any problem, because here you are applying a simple formula, but here it's a different approach to solve the problem. It's a better understanding of the problem.